Yes, I am Simon Stewart, SHS96C on Twitter. That used to be my university handle when I was at university, which is why it's like this weird combination that looks like a sort of password. Very rubbish password, because it's only 6 characters long. I am the creator of WebDriver, which is almost 11 years old now. I became the lead of the Selenium project about 9 years ago, maybe a bit more. And at Google, I worked on scaling out Selenium there from a few tens of thousands of tests to a few million tests every day using the infrastructure that we had. But after that, I went to Facebook. And right now, I am working on the W3C WebDriver specification, which is part of the Web Browser Tools and Testing group at the World Wide Web Consortium, which is taking WebDriver and turning it into a standard, which will be nice. So in this talk, what we're going to do is we're going to take a simple test case, and we'll scale it out. We'll make it run from just your machine to running on the cloud and being very impressive and the kind of thing where your manager will stroke his chin and go like, you deserve a pay rise. That's why we write software, right? So first principles, let's just remember why do we actually do testing at all? Like, it seems like a strange thing to do, right? We don't write tests because we like the color green, or actually the color red in most cases. There was always a joke about, like, in China, red is a lucky color. And so my test suites are very lucky in China. We don't do that because we like color. We don't even do it because we enjoy the job. We write tests to provide confidence that software being released to production works as intended. I mean, that's the only reason why we do it. So end-to-end tests, these Selenium tests, should be part of a balanced diet. If the only thing you have is end-to-end tests, you're causing yourself a whole world of pain. But we'll do more of that later. Let's start with a really simple first test case. Your first test. Here it is, entitled Long and Wrong, the ideal combination for a test. And I have it open in an IDE. So, there we go. Let me just get to the IDE. Here we go. So, what we do, we create a new Firefox driver. So this is running locally on our local machine. We create a new WebDriver wait. This is part of the explicit waits that we have. We then go to localhost port 8080. We sign in using an email and password. And we wait until this element has appeared, create a to-do, which we then click on. We then switch to the active element. I mean, you can all read, right? Yeah, I don't need to read out every line of code. And you'll see that we do lots of fun things, clearing due dates. And then we find elements, and we do this sort of crazy thing where we go, hey, I can't find anything. So, switching back to the presentation, bam. I have a video of this. Now, what will probably happen, I can run it locally, and it will probably open a browser window on the display I have right here, which is why I have a video. There it is, opens a new window, signs in, all very good. We've all seen a Selenium test run before, right? There was nothing particularly unusual there. So why was this test so awful? Well, the first thing was, it kind of worked by luck. At no point are we, like when we get the page, we don't wait for this first element, this sign-in element, to be present. And so we're relying on WebDriver's guess of when a page is loaded to be correct. And on this case, it's just rendering straight HTML, and that's fine, but it's going to cause problems. Where's my mouse cursor? I will find it. Here we go. More importantly, there's a certain amount of craziness that's going on here. This driver find elements by tag name, and then we filter and we look for one called create, and then we find the first one, and this is a streams API from Java 8. We find the first one, and if we don't find it, then for some reason we throw an assertion error, and only then do we click on it because we know that we have these things. That's pretty awful. I think we can all agree. And in fact, it's so awful that on this slide, I highlighted it in green, and the presenter notes underneath say, what? Now, this is bad because it's incredibly fragile, right? There are other ways of writing very fragile locators in WebDriver and Selenium. One of those is really long XPaths. Does anyone use really long XPaths? No. How long is that? If it takes up more than a line, if you have to line break it to make it fit, and if you send it to someone and they go like, is that line noise? Like that's too long. So fragile locators are one of the primary reasons why test cases are just awful. And there's a whole bunch of things you can do. In the room next door, there's a talk about Selenide, which is aiming to do that and try and help that. But there's a few things that you could do. The first thing is you can get the application under test to help. Hopefully, you all have access to the source code of the app under test, and you can make modifications to it. Can you all do that? Because I've worked with teams who are like, oh yeah, the code is that one team is in like the UK and the test team is in Romania, and they basically talk by just filing bug reports with each other. This works. Well, I've got a test that says it doesn't. Yeah, but it works for me. If you have access to the code, you can add meaningful identifiers to elements, which is nice, right? You can add classes or particular attributes or things like that to make it easier to find a class. But you can also ask Selenium to help. It's possible to extend the mechanisms we use for locating classes. So, exit out of this again. Go into IntelliJ. Find by attribute. Okay. So, hopefully you found like WebDriver.find element, and then it takes a thing called a by. You can subclass those yourself. So here, I have written a find by attribute, where what we do is we find every single element by CSS selector star. So that finds every child element and every grandchild and all the way down. It finds the entire tree underneath. And then we filter by mute. Have I turned it off using only my... Can you all hear me? Okay, that's the wrong question to ask. Hands up if you can't hear me. That's also wrong. So you could do this, but this is grossly inefficient, I think we can all agree, because you've got to iterate over everything. And every call to a WebDriver or a Selenium API is actually a remote procedure call. It has to go across the wire somehow to something else. So what we could do is this, which is execute a bunch of JavaScript that basically does exactly the same thing. Now, this looks way more complicated and a lot more frightening. But basically, we take the context and we say, are you actually a WebDriver? And we go, yep, it is. If it isn't, then we ask it whether it's this thing called wraps driver. And it turns out that remote web element wraps driver, so you can get the underlying WebDriver instance from that. So you can get that, and then you can cast it to execute JavaScript, a JavaScript executor, and then you can do your bits and pieces and things like this. And one of the things that I'm not sure everyone knows is that you can return elements and other things from execute script. So you can go into the page, you can ask the browser to do a bunch of work, and then you can return the result of that work back to you, and it'll be cast in the correct way. So this kind of code here will work. And so when you're writing your tests, and you're going, oh, it'd be really nice if your underlying JavaScript framework has a mechanism for finding elements, even if it generates random IDs. Well, ask that JavaScript framework to give you the elements. It'll do it for you. Life will be good and easy. And then the other thing is this waiting, right? And we can see an example of this. This is the wait interface from Selenium. It is exciting. I hope all of you have seen this. Has anyone not seen it? Is it brand new? There's one person at the back going like, I didn't know this existed. It's wonderful. So Selenium has two kinds of waits. It has a thing called implicit waiting, where you can manage the timeouts, and you can say, implicitly wait for some random period of time. And it has these explicit waits. The advice of the Selenium team, the people writing Selenium itself, is don't use implicit waits. Do use these. And why is that? The problem is, and people tend to not really know how long they should be waiting for. And so they set the implicit wait timeout to something like, I've seen up to a minute before. And if everything's working well, that's fantastic and it's not a problem. But if it's not working well, if your test is failing, then your test will take an extra minute to fail. And so a test run that will take 5, 10, 15 minutes can take several hours if it's failing and you have the implicit wait timeout too high. And it also plays really weirdly with the explicit timeouts. If you have an explicit timeout that's shorter than the implicit timeout, it turns out the implicit timeout gets treated as the thing we care about. It's just incredibly confusing. And so you end up with these sort of unmaintainable tests. And that's horrific. But you can use them. So let's go back to here. There we go. Dum, dum, dum. So here's our original test, and it wasn't doing any sleeping. The naive thing to do is like, go, okay, fine, I know I need to wait at certain points, so I'll just do a thread.sleep. So here we go. We wait for some arbitrary period of time, and we hope that it comes back. There we go. This is going to be entertaining. Like the volume goes here occasionally, and the video goes there. Shall I do the classic computer science fix and turn it off and back on again? We'll see. If it carries on working, that's good. Maybe if I stay completely still, maybe there's like some sort of thing that's just holding on by the skin of its teeth. Every time I move, it goes like, no, I'm not doing anything. So one way to do this is with waits, with thread.sleep. Now the problem with this is that your test will just wait too long. Right? Everything could be done within 1 second, and then you're just sitting there wasting time for 2. So you don't want to do that. What you want to do is you want to use the wait class. And the nice thing is that it uses generics. So anything that comes out of the function you pass in will be returned from the until statement. So you can write things like wait until, find an element, and so that returns a web element, and so it's okay to call isDisplayed. So you can do this thing. The other thing which you can do, which is kind of nice, and which people seem to avoid doing, is to hold a reference to a web element. Quite often I go onto client sites and I talk to people, and every time they want to interact with an element, they look it up again. Right? That is every time 2 RPCs to make 1 action call. So you want to get the title, you do the find, you do the title. You want to get the value, or you want to send keys here. Often you'll see driver.switch2ActiveElement.clear, driver.switch2ActiveElement.sendKeys, and it's like, it's the same element. The only time it might not be changed underneath you, and you might get a stale element reference exception. Does everyone love them? They tell you a lot about your application. What they tell you is that something has redrawn that DOM. And the thing that you thought was there is now no longer there. And that means that you've missed the chance to put a wait in. Like you should wait until that element is present. So you can do this, and this code will run optimally fast in that when it runs, it will do the bare minimum amount of waiting, and then it'll go. I'm going to hit Control-Shift-F10. I'm going to run the test, and we'll see what happens. It's probably going to open, yes, on my window. So you didn't see it, but I assure you, it looked exactly like the other video that I showed you. With me so far? Hopefully none of this is new. Some of it might be, and that's good. So waiting, grey box testing, again. There are things you can do to make these waits more efficient. One of them is, I've got a utility method here, is jQuery done? So jQuery keeps track of how many active operations there are. And you know that it's gone quiescent. You know when it's no longer doing anything, when its active count goes to 0. So why bother polling the page and trying to do various bits and pieces when the JavaScript framework you're using will tell you. And Angular does this too. I think React has something similar. They all have some mechanism for tracking it. But maybe the library isn't the right level. Again, you can get your application to help you. If you're doing something and you're making an AJAX call and you want to know whether that's completed, sometimes they don't redraw the DOM, right? They just shovel new content in. And so you go like, oh, I don't really know when I should be continuing my test because nothing's gone stale and everything's remained exactly as it was. Well, just set a variable before you perform an operation, and when it's completed, get your application under test to clear that variable. And then you can just check for the presence of that, and when it's completed, then you know it's safe to continue. And finally, let Selenium help. Those stale element references tell you something. If you're doing something where you expect a DOM element to be redrawn and removed from the DOM, before you perform the action, get a reference to it, and then do the action and wait until the stale element reference is thrown, and then do the lookup for the replacement and return that. And the way that the WebDriver wait works is you can ignore certain exceptions. And so that could be made really clean and nice and easy to use. And that means that Selenium takes some of the strain. And those signals that we tell you that the DOM has changed, that something has moved underneath your test, can then be used and leveraged to provide you with more stable testing. All good? We all know about weights? Who here is familiar with classical Roman mythology? A handful of people. Do you all know Janus? Janus was the two-headed god who looked into the past and the future. It's why we have the first month of the year, January. Page objects are commonly misunderstood. Like, for a while at Selenium Conf, people would do presentations and like, I'm going to automatically generate my page objects. And would find elements and it was supposed like located. That is wrong. That is not what a page object is. I mean, it's nice because you get to be fancy, right? And you get to write a framework, and writing a framework makes you look cool. I've written a framework. Clearly, that's not true. So the original definition of a page object is that facing one way, you have the user-facing services. So the application under test, this to-do thing that we have, has a sign-up page. So you want to sign up as a user. You want to speak the language of the domain that you're testing in, so that when you call over a business analyst or the project owner or your mum and dad and you show them the test, they can go like, yep, that looks like it's doing the right thing. And it's only facing the other way that a page object has deep knowledge of the code and structure that makes up the page. And the idea here is you're going to apply the don't repeat yourself, DRY, pattern to this, where you sort of abstract away. And to help you, Selenium has a class called loadable component, which you can use. And the idea here is it's called a page object. It should really be called like a thing in a page, because you can model down. You can get smaller and smaller and smaller. And it just so happens that I have a test that uses page objects. I'll make the text really, really tiny, and then everything will disappear. That'll serve me right. All right, there we go. Lovely. So this does exactly what that other test did. Let's try this. And it finished. Dun, 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 dun. I plugged it into the other port. There we go. And we're back. It's back here, it's back there. There's a little monitor down here where I can see everything. So when it goes black there, just go, it's gone again. So let's imagine it's there. And you can see quite clearly, very quickly, just memorize this. Take a photograph. I have a spare adapter. If at first you don't succeed, try again and then stop, because nobody likes to look like a fool. While we're waiting, I'm going to do a little dance. It's back there, it's back there. Right. So you can see here, this does exactly what the original test did. I'm just going to carry on. It's got this thing, new user, and we create a new user because that's what we want to do. And then we go to a sign-up page, and we pass that sign-up page a driver and a maximum time to wait, and then we go and get it. And this follows the model of the loadable component that we have. Now, the sign-up page, when you've got it, we can then sign up the user that we've created, and it returns us the main page. Wow, this is even worse. And it returns you the, look, there's more ports, I can use these. I mean, the worst thing about these Macs is there's like 1 million different ports on it, and they're all the same. The really good thing is there's 1 million different ports on it, and it's all the same. So the nice thing with this pattern, with the page object pattern, that as implemented in this test, which you will hopefully see very briefly, is, look, it's doing navigation. So if the sign-up page no longer goes to the main page, then you can change the signature, and then your tests don't even need to be run because they won't compile. You'll be able to see that they're incorrect and wrong. And then we go to the main page and we create a new to-do with title, presentation, user, and email. Just to show you the application under test. There we go. Bam. We'll go to localhost, port 8080. It is a simple to-do application, so we can sign in. We can do foo@bar.org, type in the top secret password of foobar, and it's just a simple to-do list. Right? It isn't very exciting. Demos shouldn't be exciting. They should help illustrate points. But that, hold on, here we go. Let's just get this back. So this is what it looks like with weights in. And we can go into one of these things, and we can see, we really can see, that all we're doing is we're finding elements. So we're taking all that code, we've abstracted it, and we've moved it in here. Now, the nice thing is, if we change the code of the sign-up page, this is the only place in our entire test suite that we need to fix things. So when your developers change your UI workflow, or they rename various bits and pieces, rather than having to go through 1 million different tests and change it, you can fix it in one place, and your life will be sweet. And it's always nice when your life is sweet, right? But enough of the basics, right? What we have right now is we have a test that is easy to maintain. And that's probably a good thing, right? So one way of scaling Selenium is to just have tests which actually work and which are maintainable. I went to a client site once, and they'd been told that their job was to keep the test suite green. And what they'd done is they'd removed all the assertions from the tests. And if there was ever an exception, they'd just return out of the test and they'd go, yep, that's fine. And so sure enough, the test suite was green, but it told them nothing. So a maintainable test case is super important. But there's another thing that's really important for your test cases, and that's your data. It is unlikely you are working on a completely stateless application. You probably have users, you probably have persistent data, you probably have bits and pieces that you need to get into. One of the problems you run into when you're trying to scale out your tests is your data. There are a few guidelines. When you're preparing for parallelization, which I'm only going to say once, there are a few things. The first thing is static in Java, or the singleton pattern in general, is evil and should be avoided. Why should it be avoided? It's because when you use a static keyword on a variable, if you've got a field that's marked static, it means that it's shared by every single thread, which means that if you try and modify it in 2 tests at the same time, who knows what's going to happen? I quite often, when I go to a client site, see the static keyword being used to keep the WebDriver reference. And they go like, we run our tests in parallel, and it just goes insane. Like you run it, and sometimes it works, and sometimes it doesn't. And it's because there's a race condition, where two things are trying to modify the static at the same time. And sometimes it works, and quite often it doesn't. So normally when people go like, we should avoid statics, that's great. They move to thread locals. Thread locals are also evil and also wrong. They rely you to have thread affinity when you're running a test. So you're always going like, this test will always be running on this thread, and so it's safe for me to like teleport data from this level to this level. Things like that. The fact you're trying to teleport data around, like your WebDriver instance or the username or something, is in and of itself a code smell. It means that your tests aren't structured in a way that allows them to be composed in an elegant way, and that probably means they're hard to maintain, and that probably means and a test that's hard to understand is incredibly painful. Like one of the guys that I used to work with, in order to debug a failing test, you need to be twice as clever as when you wrote it. So if you write a test at the limit of your ability to understand and comprehend, when you come to debug it, you're stuck. You're in a really painful place. So one of the things that we've learned from the rise of functional programming in Java in particular and around the world is ideally code should be immutable and stateless. Right? So when you create it, if you've got a to-do object like you saw in that test earlier, it's immutable. Every time I went in there and created something, it actually created a new instance and returned it. Mutable state is terrible when you have two threads acting on it, because it's just absolutely horrible. So I have a video of something going wrong. Shall we watch the video, or shall we? Builds remaining, 1. Excellent. So I think this is where we have a user, Fred, at example.com, and he has a password. We're going to run the test once on a clean installation of the application. There we go. Excellent. And you'll see it passes. And then what we'll do is so nothing has changed. Unfortunately, nothing has changed. You're reusing data, and the two things are clashing. So that's kind of painful, right? And I'm sure you've seen that happen all the time. The correct thing to do is to try and set up the data uniquely for the test. And you don't often see this because quite often you end up sort of resetting your developer environment between each test run and things like that. It's normally okay until you add continuous integration or a continuous build into the process. And then suddenly it'll work fine, and then it'll fail because somewhere, as you scale these things out and you run these tests in more and more places, which is another form of scaling, right? Horizontal scaling, where you run the same test in lots of different places. As you do that, the chance of data clashing becomes far, far higher, and you end up with these inexplicable failures. So what you should really be trying to do is set up the test data in the test itself. But there's a problem. It's the ossification of data. So ossification, for those of you at the back, this is quite small, it's the hardening into a bony substance. So you take something that's plastic and malleable and easy to change, such as your code or your data, and it becomes harder and harder to change. So when you're in your developer environment, you probably have your own databases that you can inject code into, things like that, and that's great. But by the time you get to production, injecting random data into production is normally considered a bad idea. I mean, you could do it, but it would be really nice if you could run your tests against production just to go like, hang on a second, does this work? And you probably don't want to run every test, right? But you do want to make like, I've released, and now I want to do happy path through the code. And one of the things that we see is people using data builders. And so you can build data in your developer environment, and when you make assertions about the shape of that data, there's got to be a user with this username. There's got to be a user with this password. That user has to have 3 to-do items. when you make those assertions in the developer environment, what it does is it actually injects that data into the underlying data stores so that things are in the right shape. But when you come up to production, what it does is it sifts through a list of available possibilities, and you end up narrowing down the scope, and it ultimately returns you one of the ones that it knows exists in the database that match your criteria. And so what that allows you to do is it allows you to scale your test from running on your local machine all the way up to production. Now, how you do that is entirely up to you, so I haven't got a demo of it. But just be aware that data, the closer you get to production, ossifies, becomes harder and harder to change. Here is a classic web application. It uses a web server. The web server collects user data. The user data is stored in a database. It also uses an authentication service, and that authentication service uses LDAP to figure out whether the username and password is correct. So this isn't a particularly unusual setup. But if you were to run this test and say the auth service was down, maybe LDAP isn't available, maybe somebody has made a real mess of doing the new version of the microservice that is the auth server. If this happens and you try and run your test suite, your tests will fail. But they won't fail because there's an underlying problem that you are trying to catch. They'll fail because there's a system that's down, and you know those things won't work. So one of the things you should be doing as your test suites get larger is checking the preconditions that are required for those tests. If you don't check the preconditions, you will end up with flakiness in the tests. Databases are down, for example. That's kind of upsetting when that happens, because suddenly a whole class of stuff starts failing. But probably any test that goes through the authentication service could still be run. Most test tools provide some mechanism for doing labeling of tests or filtering of test results. And so what you can do is you can label your tests with the back-end systems that they use, and you can either just do a check before you run the test. So JUnit has the assume class that allows you to just verify that things are good. Or you can just filter after the fact and go like, these tests all failed because we knew the database was down, and therefore that's fine. So what we're doing is we're going back to why are we testing in the first place? We're testing to be confident that the software works when it's released to production. If we know that a back-end system is down and we don't expect those tests to pass, they shouldn't be feeding into our decision about whether or not it's safe to release, because we know that that back-end system is down, and we know that that data that we're getting from our test suites is worth nothing. And your test suites are only valuable if people trust them and can rely on them. The minute the trust is gone, you might as well delete all the tests, because nobody listens to them. How many of you, by the way, have a thing where you run your tests, and then there's like a failing test, and you go, is this okay? And someone goes, oh, don't worry about that. It always fails. Yeah, delete that test. It's destroying trust. Like, it produces less value than it provides, because it's not giving you consistent signal. When it passes, it means nothing because, well, okay, that's nice. When it fails, it means nothing because, oh, we're kind of expecting it to fail. Just don't have it. So by this point, what we can do is we have user data under control, and we can run our tests in parallel across the organization. You can have 2 people running a test. That's great. We can set up data. That's great. So you can run not only lots of tests in parallel, but in lots of different environments. That's nice. That's good. We've got maintainable code because we're using page objects, or maybe the screenplay pattern that Anthony Marcono is talking about. That's great. But there's another way that we can scale, and that's by running masses of tests at the same time. Awesome power. How does Selenium actually work? I wish somebody would tell me, because it would make my life a lot easier. Underneath the remote WebDriver, which is basically everything, we have this thing called the wire protocol. And the wire protocol is basically JSON payloads being sent to URLs, and they're formatted in a particular way. And there are 2 major dialects that are out there. The first one is the JSON wire protocol, the open source dialect it's sometimes called. And that provides the functionality that you're used to, and it's implemented by the Chrome driver, the legacy Firefox driver, the Selenium server speaks it, Phantom.js does it, various other bits and pieces. And then we have the W3C dialect. And the W3C dialect is the version of the wire protocol that we have after we've gone through the standardization process. And there are two areas where it differs. First is in how we create a new session, and the second one is in actions. So if you've been using an old version of Selenium Grid, and you've been using the Firefox driver, you probably may have found things like drag and drop not working. And it's because of these underlying differences in the protocol. Just be aware of that as a basic idea. Because here is your standard Selenium architecture. When you're running on a machine, you have your tests, and they talk to the standalone server. I'm not going to fire up a standalone server. So, I mean, that's nice, but the next thing you probably want is additional nodes that you can run your test on. And that's where you can run Selenium Grid. And we'll exit. We will find over here, do we have a terminal? We do. OK. So here I've got the Selenium server standalone. If I were to start that, Selenium, so if I were to start it like that with just this, it would start it in standalone mode. But maybe I could start it as a hub. So the hub is the thing that takes the incoming requests and distributes them out. You'll see it's up and running. That's nice. Going to a web browser. Bam. Here we go. Localhost port 44. 44. There we go. Lovely. So we're in the hub. We go to the console, and there's nothing. If I were to try and run a test now, it would not work at all. So the next thing to do is to fire up a node. So I'm just going to put the hub into the background. And just to make demos really easy, if you fire up a node on the same machine as the hub, it will register itself automatically. Life will be good. See this line at the bottom? The node is registered to the hub and ready to use. So if I reload this page now, you will see that we have the standard configuration, which is Firefox, Chrome, and it knows I'm on OS 10. So it provides Safari. All good? We've seen this. The problem with this is that it's required everyone to have installed Chrome driver and Gecko driver and everything, and have set up the paths correctly, and have done a lot of work. And I'll be honest with you, it's just not trendy. And it's not trendy because it's not using Docker. If it used Docker, it would be fashionable. Right? And fashion is very important in our industry. I mean, most people here in like jeans and a t-shirt are relatively comfortable clothes, but we are incredibly fashion conscious. Like if it isn't using Docker, if it isn't microservices, if it isn't that, this, that, and the other, it's not worth doing. Fortunately, Selenium is aware of the fact that you like to be fashionable. And so there is a sub-project, Selenium Docker. I didn't understand the talk before this, but I did hear Selenium Docker being mentioned. It's a set of consistent browser images that you can use for your testing. And it avoids the problem of having to install Gecko driver or Chrome driver, or like if you're using this version of Firefox, which version of Gecko driver do you use? And if you're using this version of Chrome, which version of Chrome driver do you use? Solves all those problems for you. And so you can end up with a Selenium architecture like this, where tests talk to the Grid hub, and the nodes there are actually running in Docker containers. So let's see that. Let's kill these things. Docker compose. Compose. There we go. -F scripts. And we'll just bring up a small test grid. Okay, so this is a hub with two instances of two nodes running, one running Chrome, one running Firefox. That's nice. So if we now go to here, and we reload this page, you will see the Selenium console. I'll up the font size. you'll see that we now have one node that can run a Firefox test and one node that can run a Chrome test. And when we run those are now going to be using Docker. And Docker will enable us to scale this out. And so you can imagine adding extra nodes, right? And that's kind of cool. You will, at some point, run out of capacity on this puny laptop, which has only got 4 cores in it. So 8 threads. Realistically, you can run 8 browsers at the same time. After that, it starts crying a little bit and asking for help. But the nice thing is you can run those nodes in lots of different places, and you can have them register in. And that's great. But you know what? Sometimes, here we go. Sometimes what happens is you don't want to fire up all those nodes all the time. You don't quite know what's going to come up. You don't want to run. So what you want to do is you want to fire them up on demand. Hey, look, I've got one of these. And then the hub will go like, I know how to start a Docker instance for this. And it will fire one up on demand. And there's a project called Selenium, which enables you to do this. And it's pretty easy to use. So let's fire that up. There we go. Docker run. That looks good. Famous last words. So this is just a straight Docker run of this image, Selenium. I'm asking it to stay interactive. Actually, I'll tell you what, I'll kill it before it even starts, and then I'll do this. So we start it. It's up and running. Boom. And if I reload this page, you'll see it's going like, I could give you one of these, or I could give you one of those. If I were to run a test now, it would hit Selenium, and it would do that. And that's very exciting. And you can imagine running all these grid nodes and having it come in. So the hub could spin something up if you needed to on a super beefy machine, or you could have a mix and match thing where you have some nodes running all the time. But how many of you have easy to access Windows machines that are just hanging around in your data center ready for you to run edge tests, for example? So there's a third kind of architecture you have, where what you want to be able to do is reach a cloud provider, such as labs, testing bot, things like that. And fortunately, Selenium has a mechanism for doing that, and it's really easy. All you need to do is the difference between this and the previous command line is this source labs enabled true. So this will now pick up my source username and password, run that, and when it's up and running, I will switch back to here. Good, it's running. I'll reload this page, and now over there you can see that what it'll do is if I ask it to, it'll spawn tests on Source Labs infrastructure if it can't run it locally. There's another really nice thing that they have. They have this live dashboard that shows you everything that's happening. So let's run a quick test. Google test, there it is. I'll increase the font size again. I will attempt to increase the font size. That's tiny. That's tinier. OK, so what I'm going to do is I'm going to run a test that just does a standard Google search. You can see this locally. Run this. And I'm going to pop. There we go. And you can see in the live preview that it was doing exciting things. And then you can go to the dashboard that they have at /dashboard. And once it's gone, hey, look, I'm ready, you can just reload this page, and you'll see here that it has this sort of handy video of everything that happened with the logs being available and stuff like that. This isn't particularly outrageous, but instead of Chrome Local, what if we ran Edge? You'll notice that this is a Macintosh. It's not very good for running Edge on. No. Well, Win 10 is pretty good. The Edge team have been really, they've done a lot of work. They're really impressive. So you will see in the logs here. It's trying to create a new test slot. And you'll see here, it says just at the bottom that it's going to Source Labs in order to run the test. So if I were to log into the Source Labs dashboard right now, I'd be able to see it doing all the magic. And I'm relying on the Wi-Fi. I've got a video, so if this doesn't work, it's not a problem. But you'll see the test has gone green in IntelliJ, which means it's finished. And you'll see that it's gone and done a whole bunch of stuff. So now if I reload the dashboard, there we go, it's getting the logs. File downloaded, lovely. Do you think it's ready now? If I reload the dashboard, you can see that it's now got here the test run, and it's downloaded the video from Source Labs, and you can see it running the test incredibly slowly. Dun, dun, dun. There it is. There's the edge opening. And it goes to Google, and it types. I always search for cheese. Searches for cheese, and away we go. So what this allows you to do is it allows you to have an in-house grid of machines where you register nodes and you have hub. And then when you want to and you run out of capacity, or you just need to scale up a little bit further, or you need to provide instances that you can't provide in-house because you don't have Windows, or maybe you don't have spare Macintosh desktops lying around, you can then scale out to Source Labs or Browser Stack or a cloud provider to do all the bits and pieces you need. So there's that. And if you don't want to maintain anything yourself, you can always just scale out by going to a cloud provider straight away. The only problem with this is you put 2 copies of the internet between you, 2 round trips through the internet between you and your test. So you run the test, and it goes all the way over to the internet to the cloud provider, and then the cloud provider goes, hang on a second, routes your request through to a Selenium server running somewhere, and then that goes, excuse me, and the browser probably comes back into your internal network, doing the HTTP request, sends that data all the way back, and then the Selenium server and running in the cloud infrastructure goes, hang on, I've got the response, sends it back, and it's all incredibly slow. Like it works, but it's incredibly slow. So I try and avoid going straight to a cloud provider, but if you don't want to maintain your own infrastructure, it's one way to go. There are a couple of pitfalls as you're scaling out tests. The first is the accidental denial of service, where you run your tests, and you run so many tests in parallel that the one puny server doing all this collapses under the weight. If you start seeing random failures, do some root cause analysis. Figure out what's causing those random failures. Quite often, it'll be some piece of your infrastructure has run out of capacity, and you need to do it. Quite often, people fix problems in the Selenium test without understanding why they happen, and that means that they keep on happening, and they keep on putting more and more elaborate things. Like if you ever read your Selenium test and someone's gone hack to work around this problem, you've seen it. The other problem we see is the test ice cream cone. Your end-to-end tests form a bulk of your test cases, and you've got like an itty-bitty number of unit tests. Now, that probably makes you feel confident, and it definitely makes you feel impressive. Like seeing all the browsers go flick, 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 and running through. Utterly useless, because an end-to-end test doesn't give you any precision data. All it says to you is that something somewhere in the stack has failed, and it doesn't tell you what in the stack has failed. Ideally, you want to go to the classic test pyramid. If you find yourself in the ice cream cone and you want to go to the test pyramid, the correct thing to do is when an end-to-end test fails, root cause analysis, why did this fail? And then write the smallest possible test you can around that failure. And ideally, that smallest possible test is just a unit test. And slowly over time, you can move away from having way too many end-to-end tests, and you can migrate towards having the classic test pyramid. And so the advice I always give teams is stop writing Selenium tests. Like if you're trying to scale Selenium, it might be that you have a problem. You also sometimes overrun all the tests. Like as a belt and braces thing, you run every test you have. Not all changes require all tests to be run. If you've done nothing with the auth server, you don't need to run the tests that check authentication, because that bit hasn't changed. Build tools, modern build tools like Buck or Bazel that do graph analysis would enable you to do this, so you could run a minimal subset of tests, but even test labeling helps. And finally, try and avoid the addiction of running every test in every browser on every platform. Like, you probably feel safe, but it's also probably overkill. Most browsers now are standards compliant, so if you test everything in one browser, chances are it'll work in the other ones. So you can then run a subset of smoke tests in other browsers and just satisfy yourself that you haven't broken anything fundamental. Ideally, you'll also have JavaScript tests, which you can run in every browser on every change, and those will enable you to do things. So how do you pick those browsers? Take a look at the user data. Take a look at your logs. Your logs will tell you what people are using. That should probably be the focus of your testing, unless you know that something coming up is going to change how your users access your site. All good? Excellent. Because if you have any questions, now's the time to ask. Are there any questions whatsoever? Gentleman in a black shirt. Just behind you, actually. That
Just a second.
Oh, look, there's a microphone. And then you.
Thanks for an amazing talk.
Thank you.
So, yeah. And you touched on the problem of mixing explicit and implicit weights.
Yes.
So I read that if you mix them, it may lead to very unpredictable results. Can you tell in more detail? It's not like just you will have the implicit weight timeout. It might get stuck for very long.
So yeah, it's actually completely predictable. But what will happen is, if you execute command that causes the implicit wait timeout to be done, it won't return until that timeout is complete. So let's say your implicit wait timeout is 10 seconds, and your explicit wait timeout is 15 seconds. So you do a request, it waits for 10 seconds, it comes back and it's failed. The explicit wait goes, is 10 seconds less than 15 seconds? I'm not a maths genius, but I believe it is. And so it then does another wait, and it waits for another 10 seconds. But the problem is, you're going like, well, I told it to wait for only 15 seconds, and yet somehow it's now waiting 20 seconds. What's gone wrong? And it isn't always clear when the implicit waits are going to kick in. Find element, and when you're about to do a user interaction is a sort of woolly answer to it. And so you end up with this very predictable thing, but from the external view, if you're not aware of the interaction of how those things interact, it's looking really strange. And so what happens is, just life becomes really complicated. My advice, crank your implicit weights down to 0. Do not have an implicit weight. Rely entirely on explicit weights. And the explicit weights communicate something. Your test suite is not only a thing that verifies the code works, it's description to somebody else about how your system functions. And the explicit weight will say, like, hang on a second, we know that as part of its functioning, it's now going to do some work. It's either going to go over to the internet, it's going to do an AJAX call, something's going to be updated. And so someone reading a test can go, is that actually what it's doing now? Is that correct? Why is it doing that? And then it enables a conversation to be had that otherwise can't be had. So, I mean, they interact, and it isn't clear why, but if you just go like, is there an implicit weight happening? That takes precedence than the explicit weights. Does that make sense? Yeah.
Thank you very much. Any more questions?
Hi.
Hi.
Using JavaScript inside Selenium tests, does it make sense that Selenium is not so mighty as it should be?
I beg your pardon?
Why should we use JavaScript?
So
Maybe it should improve.
Quite often, who here uses a JavaScript framework in their application? jQuery, React, Angular, some homegrown thing which is a nightmare. Right, so the reason why you might want to use JavaScript is because you want to interact with that framework. So the example I gave was jQuery tracking how many active requests there are. There's no other way of interrogating the system and knowing unambiguously what is happening within the system. Right, so you want to be able to query it sometimes. The other thing as well is that WebDriver attempts to emulate a user's behavior. So what does a user do? They hit the browser, they type things, they click on things. There are things that WebDriver and Selenium do not do. So if you want to track HTTP status codes, if you want to have a track of network traffic, if you want to gather some kinds of logging, maybe you need to use a proxy. Sometimes there are things happening in the page where actually the best thing to do is to ask the page what the heck is going on. So an example might be, quite often IDs are generated randomly. They're used consistently, but they're generated randomly, so you can't rely on them being available every time. So what you do is you go to the application under test and you go, this thing you created, what ID have you given it? And I'll go like, oh, I've given it like ID 1234, and then you return that as a string, and then you can use that in a normal locator. So all it is it's a mechanism to allow you to do gray box testing. So white box testing, you can look inside everything and you can pull out all the internals and you can do whatever. Black box testing, where you treat the thing as it's hermetically sealed, the application under test, as if like it's come down from space and there's no way to change it. And gray box testing, what you do is you go, this is bloody difficult. And then you make it a bit easier. You go like, I'll just do this here, or I'll put in a hook there. And it's there to help you make your testing a bit more stable and simpler. You could think of it as cheating. I think of it as, like Larry Wall says, there are 3 attributes of a great developer. And those are impatience, hubris, and laziness. So impatience, I want it and I want it now, means that you will write things that are fast. And also, if you get asked to do something repeatedly, you don't want to do it at once. Machines are really good at doing things repeatedly. A lazy person is willing to work really hard once and then never again. And so laziness is about writing those tests. And so laziness, I view it as like being lazy rather than cheating. It's like, I could try and figure this stuff out, or someone could tell me, and then my life will be easier. Hubris, you just want to show off.
Thank you very much. So we don't have more time, so all your questions you can ask in discussions on.
Yep.
Thank you very much for your excellent talk.
Thank you all very much.